The normal distribution was first introduced in Chapter 2 as an example of a commonly occurring shape for population distributions. Note that the normal distribution is symmetrical, with the highest frequency in the middle and frequencies tapering off as you move towards either extreme. An example of the normal distribution is shown on the slide. Statisticians often identify sections of a normal distribution by using z-scores, as shown on the slide. You should recall that z-scores measure positions in a distribution in terms of standard deviations from the mean. Thus, z equals +1 is one standard deviation above the mean. Z equals +2 is two standard deviations above the mean, and so on. The graph shows the percentage of scores that fall in each of these sections. For example, the section between the mean, z equals 0, and the point that is one standard deviation above the mean, z equals 1, contains 34.13% of the scores. Similarly, 13.59% of the scores fall between 1 and 2 standard deviations from the mean. In this way, it is possible to define a normal distribution in terms of its proportions. That is, a distribution is normal if and only if it has all the right proportions. These proportions apply for both the right and left sides of the distribution, positive and negative sides. You are now going to get introduced to how we use the standard normal z-score table located in Appendix B, pages 571 to 574 in your text. Please open your book to that table so you can follow along and work the problems as I discuss them. A portion of the unit normal table is shown here on the slide. This table lists proportions of the normal distribution corresponding to each z-score value. In essence, it has pre-computed proportions that map out the areas under the bell curve. Linking the information in the table with the probability ratio you just learned, think of each value listed in the table as the resulting proportion of one possible outcome out of all possible outcomes. Notice that the table is structured in a 4-column format. The first column, A, lists z-score values corresponding to different positions in a normal distribution. If you imagine a vertical line drawn through a normal distribution, then the exact location of the line can be described by one of the z-score values listed in column A. You should also realize that a vertical line will separate the distribution into two sections, a larger section called the body and a smaller section called the tail. Columns B and C in the table identify the proportion of the distribution in each of the two sections. Column B presents the proportion in the body, the larger portion, and column C presents the proportion in the tail. Finally, we have added a fourth column, column D, that identifies the proportion of the distribution between the mean and the z-score. Using the portion of the table shown on the slide, you should verify that a vertical line drawn through a normal distribution at z equals plus 0.25 will separate the distribution into two sections, with the larger section containing 0.5987 or 59.87% of the distribution, and the smaller section containing 0.4013 or 40.13% of the distribution. Also, there is exactly 0.0987 or 9.87% of the distribution between the mean and z equals plus 0.25.